In this video lesson, we're going to look at the wagon problem. Wagon problem is basically such where you have some sort of object and it's being pulled at a constant velocity. So it tells us that a wagon is being pulled at a constant velocity at an angle of 30 degrees above the horizontal as shown. The wagon and child together have a mass of 60 kilograms. Draw the force diagram, write the equation that describes the forces in the x and y direction, and then calculate what's the value of the normal force and what's the value of the frictional force. So let's first start out with the force diagram. I'm going to draw my wagon and child with a dot. First things first, my force gravity needs to go down. Now, what is touching the wagon and the child? First of all, it's on a straight, flat, horizontal ground, so force normal would point straight up. Secondly, we see that the object is being pulled at an angle of 30 degrees above the horizontal. So, I'm going to label that a force applied. I'm going to call it a force applied and not a force tension, because a force tension is specifically a string, rope, or cable. So I'm just going to call it a force applied, but the idea is still the same. Now, this needs to be split up into its x and into its y component. So we have force applied y and force applied x. And then finally, it tells me that it's moving at a constant velocity. So that means that this force applied x right here needs to be balanced. And so that must mean it needs to have friction going to the left. And then I don't want to forget to put in my 30 degrees right there. Okay, so that's my force diagram. Next, I need to write the equation that describes the forces in the x direction. Alright, so sum of the forces in the x direction are equal to, I have force friction, and I have force applied in the x. Since it's moving at a constant velocity, I can say that they should be equal to 0 since they're in equilibrium. For the y, I have sum of the forces equals force normal plus force applied y plus force gravity, and that is also equal to 0. Finally, it says what is the normal force and what is the friction force. Okay, now we need to start doing some math here. First thing first, I noticed that it is 60 kilograms. Okay, so we have 60 kilograms is the mass of the child and the wagon. So 60 kilograms times 10 is going to give me a force gravity of 600 newtons. Alright, now what else do I know? I know that it's at an angle of 30 degrees above the horizontal, and the problem should say, I apologize, it should say something like how much the towing force is or the force applied. So I'm going to say that the person is pulling with a force of 250 newtons, because you need to know that for the problem. Alright, so this force right here is the 250 newtons. Okay, the first thing it wants me to solve for is what is the normal force. Now in this case, the normal force is not equal to gravity. And the reason for that is because you have force normal plus applied y plus gravity has to equal 0. So force normal and force gravity are not going to be equal to each other. Think about it this way. Your force normal is pointing up, your force applied in the y is pointing up, and your force gravity is pointing down. Since it's in equilibrium, I know that the gravity, which is 600, has to be equal to the force normal plus the force applied y. Alright, so if I can figure out what force applied y is, I can figure out what force normal is. So I'm going to do that using my trig. Force applied y, notice, is opposite of the 30-degree angle. And I know the hypotenuse is 250 newtons. So sine of 30 degrees equals the opposite, which is the force applied y, over the hypotenuse, which is being pulled at 250 newtons. Sine of 30 is 0.5, and that's equal to force applied y over 250. If I times 250 by 0.5, I end up getting force applied y is equal to 125. Now, if I look back at my equation for the y direction, the sum of the forces is equal to force normal, which is what I'm solving for, plus force applied y, which I now know is 125 newtons, and then plus force gravity. But since gravity is down, that's really saying minus 600 newtons. And that all should equal 0. So if I solve for my force normal, I would end up getting a force normal of 475 newtons. All right, now let's go ahead and look at friction force. Friction force is right here in my equations. So if force friction plus force applied X equals 0, that's really saying force friction is just the opposite of force applied X. So if I can figure out what force applied X is, I can then know what force friction is. Notice that force applied X is going to be adjacent to the 30 degrees. So that would be cosine of 30 degrees equals adjacent, which is force applied X, over hypotenuse, which is 250 newtons. If I take cosine of 30 and times that by 250, that's going to end up getting me my force applied in the X as 216.5 newtons. And remember, force applied in the X is the same thing as force friction, just in the opposite direction. So my force friction is 216.5 newtons. Specifically, it's to the left. But notice that when I report my forces, I only do the positive version of them, or the absolute value. So force friction is 216.5 newtons, and force normal is 475 newtons.